So molecular and empirical formula. So this topic is easy, requires calculations, requires a understanding of ratio. That is all that it requires. Again, if your ratio part is not clear, then you might face some difficulty. So we'll explain this with the help of these examples. So for example, my molecular mass, my molecular formula is 6C6H6, but the ratio of carbon and hydrogen in this molecule is 1:1. So this is my molecular formula, and this is my empirical formula. Is it making sense?
Yeah.
So again, this is one of the topic that you have already done in ICSE. So usually ICSE students don't face much issue, but then few of the ICSE students haven't done the stoichiometry well, especially from the last session. Shivang is one of those people, so that is why he is struggling with stoichiometry now. Okay, so this is the molecular formula,
Yeah.
and the empirical formula is just the ratio of carbon and hydrogen.
Mm-hmm.
So empirical formula in a way is a sort of the skeleton formula. The skeleton formula, just the bones, just the bones.
Okay.
It talks just about the ratios, just
Mm-hmm.
the ratio. So we'll see this with examples. So oh, that thing has vanished. So for example, C6H12, the ratio is CH2, 1:2. If I take H2O2, the ratio of hydrogen to oxygen is just 1:1. Na2CO3. Here the empirical formula and the molecular formula is the same. Is it making sense?
Yeah.
B2H6, the ratio is 1:3. This one is not written. This one is not written.
Mm-hmm.
It is understood that this is 1. So N2O4, the ratio is 1:2. So this is the empirical formula, and this is the molecular formula,
Molecular
and this is the empirical formula.
formula.
But then there would be compounds like H3PO4. Here the molecular and the empirical formula is the same.
Okay.
So for example, Fe2O3. Here the ratio is 2:3. You can't do much about it. So
Yeah.
the molecular formula and the empirical formula is the same. But if you
Hmm.
see C2H2, then the ratio is 1:1. So this would be the
Yes.
empirical formula, and this would be the molecular formula. Again, if you see N2O5, I can't do much about the ratio. I I'll
Mm-hmm.
just I'll just write it as N2O5. That is it.
Yeah. Okay.
Now I want to tell you something, and
Hmm.
you'll have to keep this in mind when you are doing uh, questions regarding this. The sort of a bit complicated questions regarding empirical and molecular formula. So there would be times we'll discuss those just in a minute. So there will be times when your ratio comes to be say uh, this your ratio of nitrogen to oxygen comes to be 1:2.5. Now an atom can't be in the form of 2.5, so that is why the ratio has to be written as 2:5. Is it making sense?
Yeah.
We'll do examples, don't worry.
Yeah.
And again, using one or two of these examples, I want to clarify another thing, so that when we are doing these complicated questions regarding empirical and molecular formula, your concepts are clear. So for example, take the case of H2O2. Now H2O2, the molecular formula, and HO, the empirical
Empirical.
formula.
Hmm.
The empirical formula. See, the mass here is 2 plus 32 is equal to 34 gram per mole. Is it okay?
Yeah.
But the mass here is 1 plus 16 is equal to 17 gram per mole. Is it okay?
Yeah.
Now say for example, I am able to derive the empirical formula as HO of a certain compound. I am able to, with the information provided, I am able to find out the empirical formula of a compound. And then I see that the empirical formula, as per the empirical formula, the mass is 17 gram per mole. Now somebody tells me that the molecular formula of this compound, find the molecular formula of this compound. The information that the person is giving us is that the molar mass of the molecule is 34 gram per mole. Should I repeat what I've said?
Yeah.
Okay. I am able to derive the ratio. There is a compound X compound.
Okay.
This X compound is an unknown compound. This is an unknown compound. Yeah. Now, what I am able to derive for this unknown compound is that it just has hydrogen and oxygen, and the ratio of hydrogen and oxygen is 1 is to 1. Is it making sense?
Yeah.
And I understand that this is the ratio only. So, this is the empirical formula. Is it making sense?
Yeah.
But then I am provided with some additional information. Then I am provided with some additional information. The additional information that is provided to me is that the molar mass of this compound X is 34 gram per mole. Is it making sense?
Yeah.
The additional information that is being provided to me is that the molar mass of this compound X is 34 gram per mole. Find the molecular formula. Have you understood the question, or should I repeat again?
Yeah. Yeah.
You have understood?
Yeah.
Okay. So now we'll be doing question regarding this concept. I wanted to spend some time on this core concept, that how do we understand that how to derive the molecular formula, how to derive the molecular formula using the information which is given to us regarding the molar mass and the ratio that we can calculate. So we will have two facts with us. One fact would be the molar mass of the compound. The other fact that we would have would be the empirical formula of the compound. Using fact 1 and 2, we'll have to derive the molecular formula of the compound. Is it making sense?
Yeah.
Okay. Now using the empirical formula, what is the information that I have? The information that I have is that the ratio of hydrogen to oxygen atom is 1 is to 1. Are we clear about this?
Yeah.
Using the empirical formula, I can see that the molar mass as per the empirical formula should be 1 plus 16 is equal to 17 gram per mole. Is it making sense?
Yeah.
Okay. But as per the molecular formula, the molar mass is 34 gram per mole. Is it making sense?
Yeah.
I take the ratio of the molar mass as per the molecular formula and divide it by the molar mass as per the empirical formula.
Okay.
The ratio is 2. Therefore, I'll have to multiply both sides by 2 and 2. Why? Because now when I calculate the molecular formula, it will be 2 plus 32 is equal to 34 gram per mole, and now the things are making sense. Avantika, have you understood or not?
Yeah.
Okay. Let me take another example. Let me take another example. So, for example, the empirical formula that is given to me that I am able to derive is NO2. This is the empirical formula. But the additional information that is given to me is that the molecular formula of the compound is 64 plus 28. The additional information that is given to me is that actually the molar mass of this compound is 72 gram per mole. Now, when I look at NO2, what I understand is that as per the empirical formula, the molar mass is 14 plus 32 is equal to 46. Is it making sense?
Yeah.
श्री हमारी कैलकुलेशन ठीक है? No, this is 92. I'm sorry. This is 92. Okay. So, as per the molecular formula, the molar mass is 92 gram per mole. As per the empirical formula, what we see is that the molar mass as per the empirical formula is 46 gram per mole.
46.
So now I see a difference between these two. And what I also understand is that 92 divided by 46 is 2. So the ratio is 2. And this is the ratio with which both sides have to be multiplied so that the molecular formula becomes N2O4.
4.
Is it making sense now?
Yeah.
So what we have understood in the past 10 minutes is that I have empirical formula. I am given molecular mass. Using this information, I can derive the molecular formula. Is it making sense?
Yeah.
Okay. So this is the discussion that we were having, that the molecular formula is equal to n into empirical formula, where n is equal to molecular formula, molar mass as per the molecular formula, divided by molar mass as per the empirical formula.
Empirical formula.
This ratio, this ratio is something which is very critical to us. Is it making sense?
Yeah.
So in the textbook also they have taken this beautiful example of benzene. So C6H6, this is the molecular formula. CH is the empirical formula. The molar mass as per the empirical formula is 12 plus 1, 13. The molecular formula, the molar mass as per the molecular formula is 12 plus 72 plus 6, 78. Is it making sense?
Yeah.
So then we see that the ratio is 78 upon 13. So 13, 6 is the 18, 13 6 the. So n would be 6, and that is why this empirical formula has to be multiplied. Both the atoms have to be multiplied by 6 so that the empirical formula becomes the molecular
Molecular
formula.
formula.
Are we clear?
Yeah.
Great.